Afternoon, everyone. I hope you people are doing well. As you all know that in this lecture, we will going to talk about the formation of mountain. Okay. So we will talk about the mountain building process in this particular lecture. I welcome you all to Careerville GS English Medium channel. My name is Shivam Pandey. So in previous lecture, we had talked about the formation of fold mountains. We had talked about how ancient fold mountains formation took place. After that, we had talked about how the formation of old fold mountains took place. Then we had talked about the formation of new fold mountain. After that, we had talked about the formation of that particular mountain, new fold mountain. Then we have to talk about the formation of block mountain. In yesterday's class only we talked about the geomorphic cycle, which was explained by W.M. Davis. We had talked about that thing also. And in block mountain we had also discussed some things like that we had discussed here, that when we talk about the mountains, when we talked about the mountains, we had talked about the geomorphic cycle of the mountains. We have looked into the fact that geographers has verified the fact that first of all there was the formation of the fold mountain took place at very first thing. Okay. Hi, good afternoon, buddy. How are you? Okay. So geographer has verified that particular thought, the fact. Now guys, in this lecture we will going to talk about the formation of block mountain. We'll continue our class from tomorrow. Formation of block mountain. This is the extension of yesterday's class. Okay. So this class is the extension of yesterday's class that we had. Now guys, remember one thing. The very first thing is that the block mountains are majorly made up of the sedimentary rocks. Remember this thing, that block mountains are majorly made up of the sedimentary rock. Why guys? Why? Because we know that block mountains are made up of the fold mountains, especially the old fold and the new fold mountains. And you people know that old fold and new fold mountains are made up of the sedimentary rocks. Okay, so this is the reason. Because block mountains are majorly made up of old fold and new fold mountains. Okay, so they are majorly made up of the old fold and new fold mountain. Remember this thing. Okay, now majorly block mountains are made up of old fold and new fold mountains. Almost 90%, 95% mountains are there. Now what is the case? Let's talk about the case. What could be the scenario? Now guys, we have the presence of Inselberg. In yesterday's class we had talked about the Inselberg, and due to the crustal irregularities, due to the seismic activities or the crustal irregularities, we have the presence of fault line over this particular Inselberg. We are talking about the process of faulting. Okay, we are discussing the process of faulting out there. Okay, after this we will talk about the reverse faulting. So here What would be the case? Due to the seismic activities, we have the presence of fault line over this particular Inselberg. Let's say this is F1 and this is F2. So this two fracture zone has divided this Inselberg into three different blocks. We have B1, we have B1, we have B2, and we have B3. Now you could see this thing that B2 is in between the B1 and B3, and B1 and B3 is holding the block B2 because it is in between of the B1 and B3. So B1 and B3 are putting the compressive force. That's why B2 is being held between these two blocks, between the B1 and B3. Okay, now guys, let's talk about the next thing. If we see this particular scenario, then we have to take some more things. Then we have to imagine some more things. Okay, because geographers has told us. So between these two fault line, beneath these two fault line, beneath these two fault line F1 and F2, we have the presence of mantle plume here. We have the presence of mantle plumes. Here we have the presence of mantle plume. And you know that mantle plume is generating the endogenic forces. Mantle plume is generating the endogenic forces. When these mantle plumes are generating the endogenic forces, that is the eperiogenic force and the orogenic force, as you can see this particular thing that B1 and B3 will diverge from B2. Okay, and B2 was in between the B3 and B1. So this particular crack will become widen. Okay, because B3 will move this side and B1 will move this side and B2 will become static. So these cracks will become widen like this. Let me draw these particular thing. Okay, the crack will become widen. How, sir? It would be like this. Let me draw this particular thing. Now, here we have the Inselberg. Okay, here we have the B1. The cracks are getting widen. Here we have the B2. Okay, and here we have the B3. So these cracks are getting widen. Okay, so these cracks are getting widen. Why? Because we have the presence of mantle plume beneath the F1 and F2. Here we have the F1 and here we have the F2. So these cracks are getting widened because of the divergent forces. Because of the divergent forces, and to be very specific, because of the orogenic forces. Because of the orogenic forces, because orogenic forces is diverging the B3 and B1 from B2. Okay, here we have B1, here we have B2, and here we have B3. Okay, now this particular line, this is the asthenosphere. So this is the asthenosphere. This particular line is the asthenosphere because mantle plumes are originating in the asthenosphere. So are we good about this thing? Do let me know in the comment section, please, everyone. So are we good about these things or not? No, buddy. No. So please tell me that are we good about or not, so that I can move further. Now, what would be the case? Now remember this thing, the mechanical force of B1 and B3 will reduce. So that's why B2, when mechanical force, remember this, when mechanical force, let me write down the things that the mechanical force of B1 and B3 will reduce, and B2 will move downward. So B2 will start moving in the downward direction because it was static. Okay, B1 will move this side and B3 will move this side. So when B2 will move in the downward direction, so it will go till the depth of asthenosphere, till the asthenosphere. Okay, it will start moving till asthenosphere. So what would be the case? What would be the case? The case would be like this. Let me draw the thing and show you. Here we have B1. Here we have the B2 that will move downward, and here we have the B3. Okay, this is B1, this is B2, and this is B3. Now guys, B2 moves till the depth of asthenosphere, and you people know that in asthenosphere we have the asthenosphere in semi-molten stage. Asthenosphere is in the semi-molten stage. So this is the semi-molten stage. So this is the asthenosphere. In which stage? Semi-molten stage. Asthenosphere is in the semi-molten stage. Now guys, now what would be the case? When we see this particular thing, that asthenosphere is in semi-molten stage, so this block, solid block, will put the pressure over this particular semi-molten liquid, and this will appraise these particular structure. Okay, this will appraised this particular structure because here we have a semi-molten asthenosphere. So semi-molten liquid will appraise the B3 and B1. Why so? Why sir? Sir, take a water in a bucket and take a balloon, okay, and press that balloon or ball, football, take a football and press that football in that particular bucket. So you could see that the water will start falling from the side of the bucket. So this will be the case. So let's say B2 is a football, B2 is pressing this liquid, and this liquid is putting the force towards B3 and B1, so they will get appraised. Okay, so this will be the case. So they will, this particular thing, okay, this particular thing is known as upwarping. Upwarping. Okay, this will be the upwarping, and this will be the downwarping. Downwarping. Okay, this will be the downwarping. This will be the downwarping. Now guys, you could see this vacant space. This particular vacant space is known as Garben or the Rift Valley. This is known as the Garben, or or it is technically known as Rift Valley. So we had talked about, and this particular two horn like structures, okay, these particular two horn like structures are known as, the horns or the block mountain. They are the horns, or technically they are known as the block mountains. So are we good about the thing that how block mountains are formed? This is the process of faulting. This is how block mountains are formed due to the process of faulting. Okay. So this complete process is known as the faulting. Do let me know in the comment section that are we good about this thing or not. Please, everyone do let me know in the comment section that are we good about the formation of block mountain. Okay. Now, buddy, this complete process is known as, the this complete process is known as the faulting. After faulting, we will talk about the reverse faulting. Remember, guys, 99% of block mountains are formed due to the process of faulting. Only 1% of mountains are there, those who are formed due to the process of reverse faulting. So, this is the process of block mountains formation due to the process of faulting. Remember this thing. This is the process of faulting. Now, what are the example of the block mountain that are formed due to the process of faulting? Let us take the example. When we talk about the example, guys, the examples of the block mountain are the Vindhyas, Satpura, Western and Eastern Ghats. Examples are just wait. Vindhya, Satpura, Western and Eastern Ghats are the examples. Okay. Examples: Vindhya, Satpura, Western and Eastern Ghat. Western and Eastern Ghat. Okay. So these are the examples. So are we good about these things, guys? Do let me know in the comment section, everyone, please. That are we good about these things or not? Now, buddy. Let's move towards the next question. Next thing. Let's talk about the next thing. That is the process of reverse faulting. Now we have to talk about the formation of block mountain by reverse faulting. Block mountain are formed, formation of block mountain through reverse faulting. Formation of block mountain through reverse faulting. Guys, remember one thing. Remember one thing. When we talk about the process of reverse faulting, the process of reverse faulting is, it is the rarest natural phenomena. Reverse faulting. Remember, it is the rarest natural phenomena. Okay. Only 1% of block mountains are formed due to the process of reverse faulting. Here we take some assumptions like on Inselberg there should be the multiple fault line. Only corner fault line should have the presence of mantle plumes and wind abrasive forces should be strong. So these three are the imaginations, these three are the conditions that have to be fulfilled for the formation of the reverse faulting. If one of the condition is not fulfilled, then reverse faulting will not be completed. So what should be the case? We have Inselberg. This is the Inselberg. Okay. We have the presence of Inselberg right there. Right there we have the presence of Inselberg. Now guys, when we have the presence of Inselberg, then guys remember one thing, we have the presence of multiple fault lines. There should be the multiple fault lines like this F1, F2, F3 and F4. The very first condition should be there. This condition should be there. There should be the multiple fault lines for reverse faulting. Second condition that should be fulfilled for the reverse faulting process, and that is the that mantle plume should present in the corner side. That mantle plume should be present. Mantle plume should be present in the corner. So it should be here beneath the F1 and the F4. So mantle plume will be there. It will exert the eperiogenic and orogenic force like this. So you could see the case. You could easily see the case. And we have the lot many blocks like B1, B2, B3, B4 and B5. So mantle plumes are present between the F1 and F4. Okay. Due to this, B2 and B4 are converging towards the B3. Okay. But in this particular scenario, you could see that B1 and B3 are diverging from each other. They are moving away from each other. That's why the mechanical force over B2 is decreasing and B2 is sliding down into the asthenosphere. So that's why B1 and B2 will get upraised, which is known as upwarming, and there is the formation of the block mountain by the process of faulting. But in reverse faulting, the situation is just opposite. In reverse faulting, the situation is just opposite. What's the situation in reverse faulting? Guys, in reverse faulting, B4 and B2, these two particular blocks are converging with B3, and B1 and B5 are diverging with each other. Remember this thing. Multiple fault line is present over the Inselberg and presence of mantle plume at the corner, and guys under the fault line 1 and fault line 2 we have the presence of mantle plumes. So B2 and B4, B2 and B4 will converge, and B3 is in the static position. So guys, due to the convergent force, there will be the upliftment in B3 and pedestal structure is formed. What is the pedestal structure? It's the flat land. When B4 and B2 will get convergent, then there will be the upliftment in B3. Okay. So what would be the case? The case would be like this. Let me take the advantage of the technology. Okay. Let me do the clone. Now, come on. Let's talk about this particular thing. So, guys, what would be the case? The case would be like this. Here, B2 is moving this side and B4 is also moving this side, and B1 and B5 are getting diverged. So this is the mantle plume. Okay, here we have the presence of mantle plume. So guys, when two blocks are converging with each other and B3 is in the static position, so mechanical force will increase. Due to this particular thing, there will be the upliftment in B3. There will be the upliftment in B3, and when there will be the upliftment in B3, a pedestal like structure will form like this, flat land. So this is the pedestal structure. Pedestal structure will be like this. So are we good about this thing? Do let me know in the comment section. Okay guys, a pedestal structure will be there. Now guys, now when we have the formation of the pedestal structure, so there should be third condition that should be fulfilled for the reverse faulting. Then guys, there should be, remember, there should be the strong abrasive force, that is the wind action should be strong. So wind action will, when wind action will be stronger in this particular situation, so it will make the frictional force strong, so abrasion will be strong. Due to the strong abrasive force, we will see the erosion, there will be the erosion like this. Let me take the dark color. Okay, now like this. This is the abrasive force, wind action. So wind action should be strong. When guys, wind action will be stronger, then the erosion will be there. And due to the erosion guys, this pedestal structure will get converted into a dome like structure, and that particular dome like structure is known as the block mountain. So it will get converted into a dome like structure. So what would be the case? What will be the case? The case will be very easy. Let me draw the thing. Just wait, guys. Give me a minute, please. Just give me a minute. It takes a few minutes. So do let me know that are we good about this thing or not. Just delete this thing. Now, come on. Now, here we have the mantle view. So what would be the case? The case would be that due to the abrasive force, here we will see the formation of a dome-like structure, like sir, like this. Here we have a dome-like structure. That particular pedestal structure will get converted into this particular dome-like structure, and this dome-like structure is known as block mountains. This dome-like structure is known as the block mountain. Okay, so this is the case. So are we good about these things, guys? So we had talked about the process of faulting and the process of reverse faulting. Now guys, now let's talk about the formation of volcanic mountain. First of all, do let me know in the comment section that are we good about the process of faulting or reverse faulting. Before completing these particular topics, we will move towards the next one. So please tell me in the comment box that are we good about this thing or not. Fast, everyone. Please, everyone. Come on, guys. Hurry up. I'm waiting for your comments. Do let me know in the comment section. Everyone, guys, please. Come on. After that, we will talk about the formation of block mountain. Come on, buddy. Everyone, tell me. Formation of block mountain. Now, guys, let's talk about the formation of block mountain. Remember one thing, that they are formed as a result of extrusive volcanism, that is, they are made up of the lava or the igneous rock. They are the result of extrusive volcanism. Now guys, before knowing the extrusive volcanism, we should know that sir, what is the volcanism? We should know about the thing that sir, what is the volcanism? Guys, when we talk about the volcanism is nothing. When semi-molten asthenospherical material reaches the lithosphere, then this particular process is known as volcanism. Okay, when, write down, when semi-molten asthenospherical material reaches the lithosphere, then this process process is known as volcanism. When semi-molten asthenospherical material reaches the lithosphere, then this process is known as volcanism. As you people know that we are talked about the interior of the earth, and in that particular case we know or we talked about the lot many things, that what is the lithosphere and what is the asthenosphere. We have talked about these things. So at that particular point, when semi-molten asthenospherical material reaches the lithosphere, then this particular process is known as volcanism. Guys, volcanism is of the two different type. We have the intrusive volcanism and we have the extrusive volcanism. It is of the two different category. We have intrusive, we have the intrusive and extrusive. Volcanism. Now guys, remember one thing. Remember one thing, that these particular intrusive and extrusive volcanism are categorized as when the semi-molten material, asthenospherical material, expose over the surface, then that is known as the extrusive volcanism. When this particular material cools down in the interior of the earth, then or in the lithosphere, then that process is known as the intrusive volcanism. We will talk about volcanism in our upcoming classes, that how volcanism took place. What are the forces behind the movement of this particular semi-molten asthenospherical material? When this material, semi-molten asthenospherical material, is inside the earth surface, then it is known as magma. And when it is exposed over the surface of the earth, then this particular material is known as lava. Okay, we have the two naming. Magma is inside the earth and lava is exposed over the earth's surface. Now guys, after this thing, when we talk about this particular scenario, when we talk about the extrusive volcanism, guys, remember in extrusive volcanism we have the formation of three different structures. In the extrusive volcanism, we have the formation of three different structures. What are those structures? The very first and the important structure is known as the volcanic mountains. Volcanic mountains. Second structure is known as the lava plateau. Lava plateau. And the third structure is known as the lava plains. So we have the three different structures due to the extrusive volcanism. Now guys, now remember one thing. What is that particular thing? Guys, now we should know something more about volcanism. Okay, that extrusive volcanism is again of the two different category. Okay, this extrusive volcanism is further divided into two different category. Extrusive volcanism. When we talk about the extrusive volcanism, they are of the two different type. We have the singular volcanism and we have the successive volcanism, singular volcanism, and we have the successive volcanism. We have the singular volcanism and the successive volcanism. Guys, when we talk about the singular volcanism, once volcanism and huge amount of lava came out. Once volcanism happens and huge amount of lava came out. Volcanism plus huge amount of lava. So it has happened in the singular volcanism. It erupts only once, and in that eruption, a huge amount of lava will came out from the interior of the earth. It only erupts once. Okay. After this, let me give you the example. The example is the Mount Krakatoa. It erupts in 1839. Guys, it has single and the biggest eruption in the history of the world. It is an island of Indonesia, and when guys it get eruption happens in this particular volcanism, that is Mount Krakatoa. It was heard till England, and guys remember, more than 35 lakh tons of lava came out from it, and ash was in huge amount. That till 6 months, huge concentration of ash was there in the atmosphere, and sun was not visible over the earth. Okay, so remember, relief features formations are found in singular volcanism. Relief feature formations are found in singular volcanism. Relief feature formation are found in singular volcanism. So eruption took place only once, but very huge amount of lava came out from the interior of the earth. When we talk about the successive volcanism, guys, successive volcanism happens regularly, and a small amount of lava came out. It happens regularly. Happens regularly plus small amount of lava amount of lava came out. Okay, this is the case. This is the case. It happens regularly, but a small amount of lava. Okay, 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 okay. Done. Done by. I'll write bit larger. Okay. So just tell me first of all that are you getting the points or not? You are able to understand these things or not? I'll write it in a big font. So before writing in big font, do let me know that are you getting these things or not? Are you able to understand? He's saying sir thoda bada likhiye. Okay, I'll write down in a big font. Come on. Do let me know. Okay, thank you. You are from which state? You are from which state? Come on. now, now, guys, after this thing, guys, remember one thing, that guys, this singular volcanism is further categorized or further divided into two different groups. Okay, Haryana, kya baat, good. So this singular volcanism is further categorized or divided into two different groups. Further division of the singular volcanism. Now, guys, when we talk about the division of singular volcanism, the division of singular volcanism are in singular volcanism, we have further two situations, like we could have single fault line and we could have multiple fault line. We could have single fault line, very first thing, and we could have multiple fault line. So these two cases could be possible. Now, what happened in single fault line? When we talk about the single fault line, here we have the volcanism, and here we have a single fault line. And in multiple fault line, it looks like this. We have more than one fault line. In singular fault line look like this. We have one vent, one opening through which lava will expose to this over the surface, and in multiple fault line we have the two vents from which lava will expose over the surface. So remember one thing, guys, from single fault line the huge amount of lava will came out, and from multiple fault line, if it is singular volcanism and there is single fault line, then a huge amount of lava will expose over the surface. And if there is multiple fault line, obviously the huge amount of lava will came out, but lava will divide in these particular two fault lines. Some amount of lava will came out from this fault line and some amount of lava will came out from this particular fault line. So the quantity of lava will divide in these particular two fault lines. Okay, so these are the things. Now, guys, now after this thing, we should know about the characteristic of lava. We know that the singular volcanism, we know about the singular volcanism, that it happens once and a huge amount of lava came out. Further, singular volcanism is divided into two different categories. We have if it has the single fault line and if it has the multiple fault line. After this thing, we have to know that, sir, what is the characteristic of lava? We should know about the characteristic of lava. You people have seen the National Geography or Discovery Channel. So there you have seen the pictures of volcanisms, okay, or the volcano. There you have seen the lava which is in black color. They always show the lava which is always in black color because they could not be able to show you the lava which is in reddish brown color. Okay, so they could not show you the reddish brown color of lava because that is the very dangerous one. Okay, come on now. The major component of lava is silica dioxide. Okay, on the basis of that content, lava is divided into two. The major component, remember one thing, that the major component of lava is silica dioxide. The major component of lava is silica dioxide, on the basis of on the basis of which lava is categorized into two parts. Lava is categorized into two parts. So what are those particular parts? What are those particular parts? So we have divided lava into two different categories on the basis of silica dioxide. Okay. So we have the acidic lava and we have the basic lava. We have the acidic lava, and after acidic lava, guys, we have the basic lava. Now buddy, now remember how we have categorized this acidic and basic lava. If silica dioxide is more than 70%, remember that if silica dioxide is more than 70%, SiO2 is more than 70%, and it is known as acidic lava. If the concentration of silica dioxide is less than, if SiO2 is less than 70%, then it is known as the basic lava. Okay, so remember this thing, the very first thing, the concentration of silica dioxide is there. After this, guys, acidic lava is in reddish brown color. It is in reddish brown color, and basic lava is in the black color. Okay, so you can easily see the lava and say which lava is acidic or which lava is basic. So it is in reddish brown color and it is in the black color. Okay, so these are the things. After this thing, remember, acidic lava is thick and viscous. Acidic lava is thick and viscous. Guys, acidic lava do not flow. They do not flow. Okay. When we talk about the basic lava is thinner and less viscous. Basic lava is thinner and less viscous. So it flow. So they flow. Remember this thing. This is the important one. What happened? Okay. So this is the case. Okay. Now, what we have to do? We have to combine the two situations. What are those situations? Guys, remember, we have singular fault line, we have multiple fault line. We have the acidic lava, we have the basic lava. So do the permutation and combination and give me the 4 different cases. What are the 4 different cases of singular volcanism? Do let me know in the comment section. Come on, everyone. Come on, buddy. Just tell me. 4 different cases. Do the permutation and combination. Singular fault line, multiple fault line, acidic lava and basic lava. Combine this thing and give me the four different result out of this particular thing. Come on. Come on. Give me the four different cases. Now, guys. Four cases of singular volcanism. Four cases of singular volcanism. What are the four different cases of singular volcanism? The very first thing, that is the single fault line plus acidic lava After this, we have the next one, that is the single fault line basic lava. Fault line plus basic lava. After this, we have the next thing, that is the next one, multiple fault line plus acidic lava. Multiple fault line plus acidic lava. And next is the multiple fault line plus basic lava. So we have the four different cases. We have the four different cases. We have the single fault line acidic lava, multiple fault line acidic lava. Next cases are single fault line basic lava and multiple fault line basic lava. So we have the four different cases out there. Okay, guys. Now let's talk about the next thing. The next thing, that is here. And what is the thing? So let's take the very first case, that is the single fault line and the acidic lava. Now, what would be the scenario in this particular thing? Now, guys, we are taking the first case, that is the single fault line and the acidic lava. This case, we are considering this case. So here we have a single fault line, and remember, singular volcanism is taking place. And I have told you that in singular volcanism, a huge amount of lava came out from the surface of the earth. So remember one thing, it is the acidic lava. So acidic lava do not flow when it came out from the interior of the earth, then it will solidify with time. So a dome-like structure, this is the fault line. This is the fault line. Okay. So from here, a huge amount of lava, it is in the reddish brown color. So huge amount of lava will came out. Huge amount of lava will came out and it will expose over the surface of the earth like this. And with time, the temperatures will get decreases and it will solidify. Okay. Now There will be, it will solidify with time. Lava solidify with, and remember guys, with time, wind action will act upon this solidified block of lava. So wind action will be there. Wind action. And due to this particular wind action, there will be the erosion. There will be the erosion of this particular lava block. And when there will be the erosion, it will get converted into a dome like shape. Okay, so it will be get converted into a dome like structure. It will get converted into a dome like structure like this. It will get converted into a dome like structure like this. So here we have the formation of the, here we have the formation of what? Of volcanic mountains. Dome like structure. Volcanic mountain. Okay. So are we good about these things? Do let me know in the comment section, guys, please, everyone. Clear, guys? Now, volcanic mountains are formed when single volcanism take place through a single fault line and there is upsurge of acidic lava. Volcanic mountains can be present on both Sial and Sima. Volcanic mountains are seen more in Sima and less in Sial. So remember one thing, that volcanic mountains are formed when singular volcanism take place. Volcanic mountains are formed. Write down this thing. Write down this thing. That volcanic mountains are formed when single volcanism take place through single volcanism takes place through takes place through single fault line single fault line single fault line, and there is upsurge of acidic lava, and there is upsurge of acidic lava. There is the upsurge of acidic lava. Volcanic mountains can be present on both, volcanic mountains can be present on both Sial and Sima. It could be anywhere. It could be at Sial, it could be at Sima. Okay. Now guys, after this thing, volcanic mountain are seen more in Sima and less in Sial. Volcanic mountains are seen more in sigma and less in Cl. Remember this thing. Remember this situation. Remember this thing. This is the important one. Now guys, we have the best example of volcanic island, that is the Andaman and Nicobar. And the biggest volcanic mountain of the world is Mauna Loa, and it is present in the Pacific Ocean. Mauna Loa technically stand at a height of 10,000 meters, and above Mauna Loa is the presence of the USA state, that is the Hawaii. Okay, so these are the cases. Now guys, let's talk about the next case, and the next case is of the multiple fault line and the acidic lava. So let's talk about the next case, multiple fault line and acidic lava. Multiple fault line plus acidic lava. Now guys, from this particular case, we will get the formation of volcanic range or the lava plateau. These two conditions are formed from this particular condition. Now guys, remember one thing. We have the multiple fault line and acidic lava. Guys, remember, we will see the two particular condition. Now, if we have the multiple fault line like this, and remember, these multiple fault lines are in the close proximity with each other. These are the fault line. These fault line are in close proximity with each other. They are in the close proximity with each other. Remember this thing. Okay, this is the case. So when acidic lava will upsurge, then that particular acidic lava will get combined with each other. That acidic lava will get combined with each other. So what will be the case? The case would be somewhat like this, that we will see the acidic lava like this. It will get combined with each other. So like this we will see the formation, because lava will upsurge over the surface and it will solidify with time. So we see the abrasive forces. So wind action will also work over them. So we will see the abrasive force. We will see the wind action. Wind action will be there. And guys, due to this particular wind action, this structure will get converted into a top flat, like a tabletop like structure, smooth structure, due to the abrasion of the wind, due to the abrasive forces. The wind will erode the topmost thing and it will become the flat structures like this. And in this particular flat structure, we will see the formation of lava plateau. We will see the formation of lava. Remember guys one thing, the condition of lava plateau that should be there, The condition of lava plateau is that there should be multiple fault line, and these multiple fault line should be in the close proximity with each other. Okay, so here we will see the formation of lava plateau. So write down, it is a series of incomplete volcanic mountain which have been flattened by the abrasive force. It is a series of lava plateau. It is a series of incomplete. It is a series of incomplete volcanic mountain it is a series of incomplete volcanic mountain which have been flattened by which have been flattened by abrasive force. Okay, so this is the condition. It is a series of incomplete volcanic mountain which have been flattened by the abrasive forces. So this is the condition. Now, if these multiple fault lines are away from each other, then what would be the case? If we see the multiple fault lines, that those are away from each other, like this, we have the multiple fault line, but these multiple fault lines are at a distance from each other. Okay, let me draw this. Like this. They are at a distance with each other. They are sharing a distance. Okay, they are multiple fault lines lies located away from each other. Okay, now in this particular thing, when lava will upsurge, here we will see that this particular lava will not get in the close proximity with each other. So here we will see the formation of volcanic range. Okay, continuous mountains are there, volcanic mountain range. We will see the formation of volcanic mountain range. Okay, here we will see the formation of volcanic mountain range. Now guys, now when we talk about the basic lava, in this particular thing, in this particular scenario, in both the condition of the basic lava, we will see the formation of lava plains, because basic lava flow, they will always form the lava plains. They will always form the lava plains. Now guys, when we talk about the lava plains, their altitude is less than 300 meters. The altitude of lava plain is less than 300 meters. So their altitude is less than 300 meters. This is the condition of lava plains. So we had talked about the formation of fold mountain. In fold mountain, we had talked about that how the formation of ancient fold mountain took place, how the formation of old fold mountain took place, how the formation of new fold mountain took place. We have talked about that how the formation of block mountain took place, and we have talked about how the formation of volcanic mountain took place, along with the formation of plateau and lot many things. Okay, so are we good about these things? Do let me know in the comment section, guys. Please, everyone, tell me that are we good about these things or not? Just come on fast, everyone. Please tell me that are we good about these things or not? Okay, come on, everyone. No, no, no. Now, from tomorrow onwards, we will talk about the topic that is the major mountains of the world. So, I request you all, this particular topic is very, very, very important for your exam point of view. So, don't miss the tomorrow's class. Tomorrow's session will be the very important for you people. Okay, so this is all for today. I hope you people enjoyed this lecture. Thanks a lot. Jai Hind. Thank you so much. Bye bye and Jai Hind. Thank you so much. Bye everyone.